exponential growth and decay applications from the study guide. There is my growth function. So I get to just plug some values in for this. Remember, this is really derived from a times b to an exponential power. But in this case, the a stands for the initial starting value. This is the growth rate, and this is the time, the amount of time that's passing. Over here to the decay, it's very similar. I have my initial starting amount. Say I have 2 people in the room and people leave. You're not going to end up with many people anyway if you have 2 people. Anyway, this is going to be the decay rate, or the decay factor if you think about it. So I have 1, I'm going to subtract the rate, and I'm going to take it to that amount of time. And don't forget, the rate is always going to be expressed in decimal form. Usually in word problems it will show you though in percentages, so let's go for it. So over here we have a population of a city is 422,000, increases. So it goes up. Oh, that's actually a pretty big growth rate. Use an Excel function to find the population after 8 years. So I have all the values I need to be successful. My starting value, so I write it out. Here's my starting value, 422,000. Here's my growth factor, if you think about. So I'm adding, so 1, that accounts for this whole unit, if you think about it. And it's growing by 12%. So I'm adding the 12%, which in decimal form is 0.12. And remember, to find the decimal equivalent to a percent, you just move the decimal to the left, because you are basically dividing it by 100, taking it to the 8th, because that's the time. I used a calculator, definitely use a calculator for this, and that's what I get. Number 29, we get a car. I already know it's going to be, oh, I forgot to box my term. Sorry about that. Anything in these problems that like depreciates or decreases, I know it's going to be decay, DDD. I have a car I bought. Oh gosh, that's, yeah, decreasing kind of fast. We're going to try to find it after 5 years. My Hyundai, what is it going to be worth? Probably nothing. Anyway, here's my starting value. Remember, this is A, if you think about it, right? And then I have my decay factor right here. So I have 1 to account for the initial value, and I'm subtracting 15% each year. So hence 0.15. And then I'm taking that to the 5th power because it's 5 years, and I'm going to calculate it out with the calculator, and that's what I end up with. Notice it's quite a deal smaller. Cars are a terrible investment, just so you know. Last but not least, we've got a painting. Ooh, paintings I know should increase over time because it's an investment. So I assume it's going to be an increase, but let's see. Got a painting. I think it's going to be, that year thing is going to come in handy. Bought it for $1,250. We have an increase, 6% each year. That sounds about right. Find the value of the painting in 2017. So this is a little bit of a hidden question if you think about it. So let's go here. Well, first of all, the initial value. So back in 2006, when I was just starting my career teaching, or even before then. Anyway, I ended up buying it, the Picasso, for $1,250. Here's my growth rate. It's not too big. So it's 1 plus 0.06, which is my 6%. And then how did I get the 11, you might ask? Well, I hope that you could figure out that I got it from there. So it's the difference in the years. Okay? So it is sort of year. That's funny. So it's 11 left over. That's silly. That would be a careless mistake, by the way. And I would carry it to the 11th power. Use a calculator. It's going to end up like this, right? After 11 years. Yeah, that makes sense going up. It's, slow increase. Bye.